Hey guys, this is Vepik. Today I would like to show you my solutions for the very fresh problems coming from IMO 2019. So let's go through the problem together. The problem is the following. In triangle ABC, we are given 2 points A1, B1 lying on the side BC and AC. Then we take a point P on the segment AA1 and Q on the segment BB1 such that PQ is parallel to AB. Next, we construct a point P1 on the line PB1 such that the angle PP1C equals to the angle BAC. And similarly, we construct the point Q1 on the line QA1 such that CQ1Q equals to the angle CBA. Then the claim is that PQ, P1, Q1 are concyclic. The key of this problem is how to use these angle conditions. So I'm going to show you two solutions, one based on angle tracing and the other based on radical axis. The key of this first solution is to introduce this additional point T as the intersection of BB1 and the circumcircle of ABC. Then now by basic angle tracing, we have that the angle BTC equals to the angle BAC, and by assumption this is also equals to the angle PP1C. And this implies that B1T, P1C are concyclic. So they are concyclic in this red circle. Now I'm going to use this concyclic property to prove that P1T, P and Q, these 4 points are concyclic. Well, indeed, we have the angle P1B1 equals to the angle TCA. And since TCAB are concyclic, this equals to the angle TBA. Finally, since AB is parallel to PQ, the angle TBA equals to the angle PQT. So this implies that T, P1, P and Q are concyclic. Now in the same way, we can define the point S as the intersection of AA1 and the circumcircle of ABC. Then according to the previous analysis, we have PQ, S and Q1 are concyclic. So finally, we are going to prove that these 6 points lie on the same circle. Since we have already proved that PQ, T, P1 are concyclic, and also PQ, S, Q1 are concyclic, so it is sufficient to show that PQ, S, T are concyclic in order to conclude. If you are familiar with Ram's theorem, this is just a simple application of it. Otherwise, I will just show you by a simple angle tracing argument. Indeed, the angle PST equals to the angle ABT. And since PQ is parallel to AB, so the angle ABT equals to the angle PQT. So finally, we have PQ and ST are concyclic, which implies that all these 6 points PQ, P1, Q1, S, and T are concyclic. I hope you have enjoyed the first solution of angle tracing. It is very elegant, there's nothing complicated, but in the first place I didn't find it. Instead, I use a radical axis to help me solve the problem. So let me show you my second solution. Indeed, this is how I construct the point P1 at the first place. So let me denote D as the intersection of PQ and AC. Then we have the angle PDC equals to the angle BAC equals to the angle PP1C. So this means PD, P1C are concyclic. In other words, P1 is the second intersection of the circumcircle PDC and PB1. And similarly, let me denote E as the intersection of PQ and BC. Then we have QE, Q1 and C are concyclic as well. Next, I'm going to introduce a new point J as the intersection of PP1 and QQ1. So in order to prove that PQ, P1, and Q1 are concyclic, it is sufficient to show that JP times JP1 equals to JQ times JQ1. And this is just another way of saying that J lies on the radical axis of these two circles, the circle PDC and the circle QEC. As you can see, this point J is not a nice point that we can easily operate on. Well, it is the intersection of the line PP1 and QQ1, but we don't have much characterization of these two lines. So let's try to transfer the problem to a nicer point. I'm going to define the point K as the intersection of BP and AQ. Then my claim is that J, K, and C are collinear. This is indeed a simple application of Papa's theorem. Well, we have two lines APA1 and BQB1, and Papa's theorem states that the intersection of opposite sides lie on the same line, which are nothing but the points K, J, and C. So K is the intersection of AQ and BP, and J is the intersection of PB1 and QA1. And finally, C is the intersection of AB1 and BA1. So we prove that J, K, and C are collinear. Finally, we are going to show that K lies on the radical axis of the circle PDC and QEC. As you can see, we have completely removed the dependency on the points P1 and Q1, which are hard to characterize. So let's see how we prove this statement. Now let's denote N as the intersection of BP and the circumcircle of ABC. Then by basic angle tracing, we have the angle PNC equals to the angle BAC, which is again equals to the angle PDC, since PQ is parallel to AB. This implies that N lies on the circle PDC. Similarly, if we define M as the intersection of AQ and the circle ABC, then we also have M lies on the circle QEC. Finally, we are going to prove that MPQM are concyclic. Well, this is again a simple application of Ram's theorem, or we can prove it by basic angle tracing. Indeed, the angle KMN equals to the angle ABN equals to the angle KPQ, which implies that MPQM are concyclic. Finally, K is the intersection of PN and QM, which is the radical center of the circle PDC, QEC, and PQMN. So we are done. Well, that's it. This is WebPeak. If you like my solutions, don't forget to subscribe my channel. Thank you. Bye bye.